squared.
Yeah. Yeah, that's exactly what we were about to go into. So good job. I'm glad you remembered. As a quick review, so a quadratic, like Aniket told us, is just an equation where the greatest term, where the greatest exponent is a squared. So you can have x squared, but you can't have x cubed. That wouldn't be a quadratic anymore. And you can see some examples of things that are quadratics and things that are not quadratics. So if you have an exponent of a 3, that would not be a quadratic. It has to have an exponent of 2 as the greatest exponent. Okay, so this week's homework review is a little bit different. And I'm not going to actually share the link with you guys. We're just going to go over it together, kind of like a lesson. Okay, so there are 3 main forms of a quadratic equation. They're basically the same thing. They create the same kind of graph, but they just look a little different. So, and they can be used for different purposes. So with these 3 equation blocks, does anyone know which one of these is standard form?
Like the one with all the y, x.
Squared plus 3x plus 5.
Yeah.
Y equals x squared plus 3x plus 5. Yeah, exactly. That is exactly correct. Good job. So standard form looks like y equals ax squared. In this case, a is 1, so it's not there, plus bx plus c. All right, let me let Kayan in. Oh wait, she's here. Okay. All right. So between the 2 we have left, does anyone want to take a guess at which is intercept form?
It's the one where it says intercepts. Like the y-intercept is 5.
I think she means
Just between these 2 right here.
I
like
think
right in the
between
middle.
those 2, it's probably going to be y equals x plus 5 and x minus 5.
Yeah,
It's
you would
probably
be
that
correct.
because that looks like coordinates.
So the 5 and then the -5 will tell you the x-intercepts, or like the roots. So that's why that's intercept form. And then this one will be vertex form, because there's 1 and then the 5, that tells you the coordinates of the vertex. And then, like I said, these match up. So something unique about standard form is that C in standard form basically represents the y-intercept, which is where the graph intersects.
Wait, so the one that said intercept on it is an intercept form?
Sorry, can you repeat that?
So shouldn't like the one you just put be on? Oh wait, there is no intercept form. Oh no, wait, there is.
No, I think I get what you're trying to ask. So intercept form tells you the x-intercepts. So we can go to Desmos and kind of demonstrate that. So let's see. Intercept form tells you the x-intercepts. So this graph will has the x-intercepts at -5 and 5 in its intercept form. And then standard form, we're just gonna make up a random one. The last number here tells you the y-intercept. So this intercepts the y-axis at 0, 1.
Okay.
Okay, Kyung, do you want to take this one?
Oh, sure. Okay. So sorry I'm a little late, but so Caroline and Andy are trying to determine which graph represents y equals x minus 1 times x minus 5. So Caroline thinks the purple one's correct and Andy thinks the green one's correct. So let's do this. If you think Caroline's correct, then like at the bottom, there's reactions on the very right. So do like a clapping hand like this. And if you think Andy's correct, then do a confetti thing. So purple is Caroline, green's Andy. So far, so don't look at my answer, by the way, I'm just like showing you. So I see like a few people are participating. And so far I see that it like goes away after a bit, but I'm pretty sure I saw more confetti, which is,
Yeah.
I think I said it was Andy, right?
Mhm.
So actually, that's like the, it's like an easy trap to fall into. But when you have x minus 1, then the root, when you set x minus 1 equal to 0, that's how you find roots, right? Setting things equal to 0. Then you find that x has to be 1. And then also for the second one, x minus 5, x, like the root is 5. So the roots are actually at 1 and 5, which means it's the purple one. Not
Okay, I'm glad. I saw a bunch of people doing confetti, and for my homework, I put the purple line was correct, so I was kind of worried for a second.
I was checking
You
on
were
my
right. I
end.
saw you with clapping hands. I'm pretty sure you're the only one who had the right answer.
Yay!
I was checking mine, but I did put the right answer.
Oh, nice. Good job.
So you can
I
see,
just didn't want to say something. I just wanted to check what mine was.
Yeah.
And I think it might have been the same reasoning you're about to say. It's because the purple line has point, because the explanation I used was x equals 0, no, x equals 1 and x equals 5. And the purple line has points on 1, 0 and 5, 0.
Yeah. Good
Therefore,
job.
it is
That's
correct.
perfect. Yeah, that's a perfect explanation.
oops. Okay. So this graph has to have an axis of symmetry at x equals 4. So that would be here. And since I did show the answers, basically, what we're going to do is a little bit different. So this is x equals 4. And as you can see, like these are the equations that produce a graph with a line of symmetry at x equals 4. So can anyone explain why that is the case, or how you can know that from looking at the equation?
I can,
All right, go ahead.
because all three of them have x minus 4.
Yeah, so x minus 4, remember, don't get confused by the negative. It's actually a positive 4 where the vertex is. So these equations are all in vertex form. And so the vertex is going to be on the line of symmetry of a quadratic. So to demonstrate that, think about a quadratic like this. The vertex, which is like the lowest or the highest point, is going to be on the line of symmetry.
I
And so that's
actually
a-
had one of the answers correct. I just didn't have the other two.
So this one, like I don't think we talked about this in class, but like the concave and convex, we didn't go over this. I'm like 99% sure we didn't. But like the ones that open up, like the one on the screen right now, those are convex. And then the ones that are like upside down, I guess, that go like this, those are the concave ones. So the actual answers are the second, third one, but like we didn't go
I
over it.
didn't see
So it's
concave
okay.
down. Yeah, if it's just concave down, then the first one does not count.
Yeah.
Okay.
Oh, a very long one. So consider the intercepts, concavity, I don't know how to say that, and vertex of each equation, then match to the graph with the similar features. So I think one's hiding under like the one graph at the bottom left corner.
Okay, which one should we start with? How about we start with this one that I'm currently using?
Okay. So somebody tell me if like the sign of the x squared term should be positive or negative since it's going down. Should it be like y equals x squared or something, or y equals negative x squared?
I think it's y equals negative x squared something.
Yeah, negative.
Yeah, you're-
Negative.
it should be negative. So we can rule out like a lot of these, right? So it's not gonna be like I can't really show you each one because that's a little annoying. But and the vertex, obviously there's no like actual numbers on there, so we're gonna have to like make an educated guess. But it's somewhere like
Wait,
It's-
if you go on a picture and then click the red line and then you hover over the dots, then it will show the exact plot. See?
oh,
What the?
you're actually right. I did not know that was a thing.
All right, thanks for that.
Okay. So is somebody tell me what the vertex is? Well, I mean, it's right there. So is there one that says like plus point something? I don't see any decimals. Or is it the one that's covered up? Like the one,
It's covered up.
like, like right there. I can't like point to it, but
Whoops.
yeah, that one.
It's not
No,
that
it's not. So then it must be like one of the non-factors ones that we can't see the vertex of. Probably the one you're looking at. Yes.
Yeah. Okay, let's put it into Desmos to see. Negative x squared minus 3x minus 3.
Yeah, that would make sense when you complete the square, but like we didn't learn that yet. So you
Yeah.
guys, if you were doing this, you would have probably just like left it for last, maybe.
Yeah, so this would be correct. It has the same vertex and the same intercept.
Okay, one down, a lot more to go. So let's do that one next, I guess. So I think it's like has an x-intercept and a y-intercept at 0, 0. Or I think. Or no, it was not 0, 0. It was a little before. Okay, so there's a y-intercept at -1. The vertex is 2, -5. How about we use that? So if the vertex is, we learned about it like HK and things in the vertex form. So I see one that you can like see right away. I don't know. I don't want to like give it away, but if it's 2, -5, then in vertex form, like parentheses x minus k, wait, no, h close parentheses squared plus k. Which one do you think is like that for 2 and -5?
-2, -5.
So that's actually a good guess, but those in that form, that would be like the intercepts, like the x-intercepts, the 2 points that are on the x-axis.
Wait, do you mean like this?
Yeah,
box?
I mean that one.
Oh, like that one? Okay.
Yeah,
Yeah, that's right.
Then you
okay.
Okay, now we have like, wait, why are there more more equations than graphs?
to trick you, I suppose.
Okay, whatever. Anyways, so this one, did we talk about having only like one x-intercept yet?
I think like vaguely we mentioned it once, but I wouldn't expect you guys to remember.
Yeah. What point is it? Like, can you click on it?
Oh, sorry.
Okay, so it's 5, 0. So it's not gonna be any of the ones that are like two different intercepts, like the one at the bottom, x minus 1, x plus 5, but it's gonna be ones that we haven't really learned. So I know which one it is, but like to see it, you would have to complete the square, that one. So just if you factored this, if you know how to factor, then you would get the right
But we're
answer.
gonna learn how to factor today.
So this might have been really hard. So sorry about that.
All right, should we like skip the rest of these?
Yeah, probably because half of it we haven't learned. So
All right,
anyways,
back to the slides.
okay, so I think we're mostly gonna focus on finding factors and like factoring in general with 2 different ways, I think. Yeah. And the VRS formulas, we'll worry about that if we have time. So last class, which was like a long time ago, we learned how to find the factors from a factored equation, one that's already been factored for us. But most of the time, math doesn't want to be nice to us and it's not factored. So you're gonna have to factor it first and then find factors like the roots. So just a quick review, I think. Wait, wasn't there a quick review? Or was that before this?
The review was like not about finding factors from factored form. And it was before.
Oh, okay, it was before. Never mind. Anyways, so then it's factoring. So how would we factor? Were you doing this?
You can do it.
Okay. X squared. Wait, hold on. Just before we start factoring, who knows how to factor? Who has like already learned it somewhere? Nobody? I mean, there's nothing wrong with that, but okay. And has anybody like done a tiny bit? Like you're not really sure how to do it, but you've maybe glossed over it a little bit. What the factor is? Huh?
Okay, we'll take that as no one knows anything about factoring.
Yeah, that's okay. We'll learn today.
Yeah.
So we know that when we factor, it becomes like the intercept form that we learned last time. So it's like x minus m times x minus n, and sometimes there's a coefficient in front of the x's too. So when we get to a little more complicated ones. But how do we change this ax squared plus bx plus c into factored form? Well, we have multiple methods, but we're going to start with the box one. This is kind of a simple one. And once you understand, you'll probably switch to some other methods like as you become familiar with factoring, but this is a good one to start with.
Okay, so starting off, our original equation was x squared minus 6x plus 5. And so for the box method, what you're going to do every time is just draw this box like that. It just has 4 spaces for you to write stuff in. And you're going to take the first term, which is like the ax squared term, and you're just going to put it into this top left box. Then you're going to take c, or like the last term, and put it into this bottom right box. So
What if
Yeah.
the 5 was negative? Would you put negative 5?
Yeah, good question. You would put negative 5.
Okay.
And so just remember that this equation is in standard form. If you're a little bit confused, so it's ax squared minus, plus bx plus c. Okay, I think we kind of go over that in the next slide. So a in this quadratic is going to be 1. Since it's 1, it's not written there, but you can kind of pretend like there's a 1 in front of the x. Well, you can understand that the 1 is there. And then b will be negative 6. So make sure not to make the mistake of thinking b is just 6. It's also negative 6. And then what is c? C is 5, like we said before. Now the first step, so the first step we're going to do here is we're going to multiply a times c. So a is 1, c is 5, and we're going to get 5. And now we have to find factors of 5 that sum up to b. So b is negative 6, and we need to find factors of 5 that sum up
All of it?
negative 6. Yeah.
No. I'm in math mode. Go get dad. Go get dad. Yeah, go get dad. Go get dad. I'm not.
Okay. And so basically you just have to think about this. You can draw a factor rainbow if that helps you. But the factors of 5 that sum to negative 6 are negative 1 and negative 5. because -1 times -5 equals 5. So keep those numbers in mind. Now, we're going to take those factors and we're going to put them into the 2 remaining boxes. And then we're going to add an x on the end. So you can put them into either box. Like you could have -1x here and then put the -5x here. It doesn't matter because it'll end up being the same thing. But just you take those factors and you put them into the 2 boxes you have left. Does anyone have any questions so far before we continue with the box method? Oh, your dad did this with you? Okay. Well, that's good. Kayan, can you let Rishikesh into the breakout room?
Wait, where do you do that?
Oh, maybe you don't have permissions. Okay, never mind.
Yeah, no, I don't see anything.
Okay. I think I got it.
Can you make me like something, like a co-host or something?
It doesn't let me. I think you'd have to get Amy to do it. Okay.
No, it's
And so now the next step, now that you have your box filled out, you have to find the greatest common factors in each column and row. So let's take this red row here. What is the greatest common factor of x squared and -5x? So you remember that x squared is just, oops.
Is it -5?
No, it's not, because you can't divide x squared by -5 and get something out. A factor is where you can like divide it by that factor and then get something even out. So remember that x squared equals x times x, and -5x just equals -5 times x. And so you can see that the greatest common factor is x. So then we can, we can write that to the side over here. And now for the bottom. So we have -1 times x we have -x and we have 5. So the greatest common factor here is actually going to be 1. Okay. Now we're going to do the same thing, except we're going to do the columns. So x squared and -1x. Does anyone
I got
know
a
the
question.
factor? Yeah.
For -1x and 5, how come it wasn't 5? How come it was 1?
Okay, well, we're looking for the greatest common factor, right? And -x you can't factor a 5 out of -x, because if you try to divide -x by 5, you're just left with like -x divided by 5. You can't simplify it down any further.
Okay.
And so if you can't find any factors, then you're just going to use 1, because 1 works with everything.
Okay. Thanks.
Yeah, so we have x squared and -x. So what is the greatest common factor here?
X.
X.
Yeah, that's correct. Good job, guys. And then on the last side, we have 5 and -5x.
5.
5.
Yeah, exactly.
5.
All right, we're not done yet, although we're almost done. Now we have to do something with the negatives. So if the box next to one of the numbers we've written, I think I forgot the x here, is negative, then the number will also become negative. So -1 is touching this box right here, and the number inside the box is negative. So this -1 also becomes negative. Same thing for the 5. The box it's touching is -5x. So therefore this 5 also becomes negative. Okay, now that we have that, we can use it to find the factored form. So basically, you're just going to take the numbers at the top here, which are x and -5, and that becomes x minus 5. And then the numbers at the side here, that becomes x minus 1. So the factored form is x minus 1 times x minus 5.
That is a very long and complicated process.
Yeah, when I explain it all out like that, it can look like it's really long, but when you get used to it, you can do it really quickly. And we're going to see a video that hopefully helps you guys see that. I think Colin got kicked out or something, so I'm gonna let him back in. Okay, so our summary of the box method, we've defined A, B, and C in the equation
Sorry.
standard form.
My computer just decided to crash in the middle of when you were saying about like factors and stuff.
Okay, well, we're going to basically review it really quickly right now. So you find A, B, and C in standard form, and then you put the ax squared term into the top left box. Then you put the C term into the bottom right box. Then you have to multiply A times C and find the factors of that add up to B. Sorry about the background noise. Then you find the greatest common factor of the rows and the columns. And then you put in the negatives from the boxes that are next to it. And then you have the factored form.
How do you find the greatest common factor once you've put all your values in?
So maybe we should do like a tiny bit of practice with that because like, you know, so it's like almost the same as like, what's the greatest common factor between 6 and 8?
2,
2.
So how'd you do that?
because 6 and 8 can both be divided by 2, and it's one of their factors, but it's the highest number that they share. They don't share any other numbers that are in greater value as a factor than that.
Yeah, perfect. That's exactly why it's 2. So 6 is 2 times 3, 8 is 2 times 2 times 2. So 2 is the greatest one that they both have. So we're gonna use
I
this.
thought 8 was 2 times 4.
4 is 2 times 2, so it's like the same thing when we do prime factorization. But either case, so it's the same thing, but now with like some letters too. So like X is a common one. You could see like any other letter could also be.
So which one are you trying to find the greatest common factor of? Are you trying to find out like A, B, or C?
No. So
Let's go back a little bit.
let's just go back a tiny bit. Like yeah, we could stop here. So once you do like all of these boxes, you've already filled it out, right? You look at rows and then columns. So first you can do rows, like it doesn't matter which order you go, but you can go like row first. So x squared and -5x. So x squared is like x times x, right? And -5x is -5 times x, right? Pretty simple. And
Yes.
yeah, so the greatest one that they both have is x, which is why we wrote it there. And then you do the same for the bottom row. So we found out it was 1 because they don't have any factors in common other than 1. And then you do the same thing for up and down. And then, yeah, you do signs, but. So this method can be a little tricky, but once you get it, it's gonna be like really fast. So let's watch a like video. to
So once you've done the common greatest common factors, what do you do with them?
So you like wrote it at the top and like on the side, right? So then after you do that, you look at the like box that it's next to. So like the top x is next to the x squared box, and then the well, it was 5. The 5 was next to the negative 5x box. So since it's negative 5x, you put a negative in front of the 5. The 1 was next to negative 1x, so you put a negative 1. And then like these are your x minus m, x minus n's. So it would be y equals x minus 5 times y equals x minus 1. Like that.
So let's watch a video, and hopefully when you see someone like using all of these steps to just solve the problem all at once, it'll make more sense.
Binomial 3x squared minus 2x minus 8. What you want to do with the box method of factoring is you want to multiply the a value times the c value. So 3 times negative 8, that's negative 24. And so we say what two numbers multiply to negative 24, but they have to add to that middle coefficient, that b value, negative 2. So in this case, it's going to be negative 6 times positive 4 is negative 24, and negative 6 plus 4 is negative 2. You want to make sure these numbers are the same in both of these scenarios. So then what you do is you take this middle term, the negative 2x, and you split it up into negative 6x and positive 4x. And it doesn't matter, you can put these either here or here, but you can see these add up to the negative 2x, the middle term. Then you put the first term up here in the upper left-hand corner and the constant, or this last term over here in the bottom right-hand corner. Then what you do is you look at these rows horizontally and you say to yourself, what's the greatest common factor? What can I divide out of both of these groups?
Okay, so 3x squared and 4x. Does anyone know what the greatest common factor is there?
X.
Yeah.
X.
Well, in this
3
case, it's just
prime.
x. When I divide this by x, I'm left with 3x. Here I'm left with 4. And then the
Okay, and then now the bottom two. What's the greatest common factor of those?
Negative 2.
Negative 2.
greatest common factor in this row is going to be negative 2. And you can see 3x times negative 2 is negative 6x, 4 times negative 2 is negative 8. And now we have our two factors. See, it's 3x plus 4 and x minus 2. 3x plus 4 and x minus 2. And you can multiply these out and verify that it gives you back this original trinomial. If you want to see more examples.
All right.
This takes me back to when my teacher was teaching me how to do to multiply two two-digit numbers, and they were using the same box. It just takes me back to that, and I was like, but you can just write it like this, and it's all laid out right in front of your eyes. You don't have to do that.
Yep.
I was never one to do those like other methods of multiplication when I can just write it out.
All right. So like you saw in the video, you can use the box method even if there's a coefficient or just like a number in front of the x squared term. And we're going to get some practice with this box method. Okay, so let's do the first one together. X squared minus 3x minus 4. So we're going to draw the box. Now, what do we put in the top left corner? Does anyone remember?
In the top left corner, we can put either
X
x
squared.
squared.
Yeah, you put x squared.
And in the bottom right-hand corner, you can put, is
4.
that negative?
Yeah,
that
negative
4?
4.
Is that negative
four.
4 or just 4?
You have to
Negative
put negative 4.
Okay.
So if
Negative
this back
4.
part happened to be like plus 4, then you would just put 4. If it's negative 4, if it's minus 4, you have to put negative 4.
Okay.
All right, and then the next step is to multiply a times c. So remember, a here is technically just a 1, and we do a times c. So 1 times
So
negative,
4x squared.
You don't look at the x's, you just do the like coefficient.
Yeah, remember.
Or negative.
Yeah, remember it's
Oh.
ax squared plus bx.
Oh, so it would be -4.
Yeah, so we got -4. And now we need to figure out what factors of -4 will add up to b, which is -3. So we need to think of factors of -4 that add up to -3.
-2 and -2.
Yeah, no, wait, wouldn't that be?
-4
No.
and +1.
Yeah, -4
Yeah.
and +1.
Good job. So -4 and 1. So as you can see, -4 times 1 equals -4. And -4 plus 1 equals -3, which is b. So good job. So these are the numbers we're going to use. And we're going to put them in here with an x after them.
And now it's time to find the greatest common factors.
Yeah, exactly. So what is the greatest common factor of the top two?
X.
X.
Okay, and now what about the bottom two?
1.
That's right. Okay, and then
Wouldn't
now,
it be -1 though?
No.
it wouldn't be -1. It's just,
But it's next to -4.
No, it's next to an X.
yeah, this one is next to the x. It's not next to the -4.
Okay.
But we're about to use what you just said in a second. So what is the greatest common factor of x squared and x?
X.
X.
Yep. And now -4x and -4.
-4.
-4.
Yeah. So 4 and then adjacent to the -4x. So we add a negative. And now we've factored it. So we take this and this. And then our
So it's
factored
X
form-
minus, it's X minus 1 and X minus, and X.
No, it's
minus
X
4.
plus 1. Wouldn't it
Oh,
be
yeah.
X?
Yeah, X plus 1 and then X minus 4.
Yep, good job. That is the correct answer. So if it's just like a 1 here, a positive 1, then you do plus.
Does that matter if which way it goes, like X minus 4, X plus 1? And could it be X plus 1, X minus 4?
I think
Yeah,
it does
that makes
matter because it's the complete opposites. It's like saying that 2 comma 3 and 3 comma 2 are the same thing. They're not.
Actually,
I think it matters.
so like multiplying is, it doesn't matter because like it's the, what is it, like
FOIL?
property that I forgot the name of.
Oh,
But it's like 3
communicative.
times 3.
Commutative
Yeah.
property.
Yeah, I think so. So
Community
2 times
property.
3 is 6. And then 3 times 2 is also 6. So like multiplication, it doesn't matter. So x plus 1 times x minus 4 is also the correct answer.
So you can
Okay.
put the actual answer anyway, but do you have to make the box like that? Couldn't you not like flip the x squared and negative
You
4
can't flip
around?
those, but you can flip the x and the negative.
So it doesn't matter where you keep the negative 4x and x in this case, but it does matter where you keep the x squared and negative 4.
Mhm. All right, so for number 2, do you guys feel ready to try it on your own? Or
Yeah.
just- Okay, so we're gonna try it on
Yes.
your own.
Let's go. Let's go.
Let's see. And then if you're stuck, you can ask for a hint on what to do next.
Don't be scared to try. If we aren't doing so good, we can work together on the next one.
Yeah.
Can you make the box on your screen, or do we have to make the box on our own?
It's probably
We're
drawing.
gonna make our own boxes.
You should
Okay.
probably just get like a piece of paper.
Okay.
You'd be like, man. Oh, crud. Stupid. So to be clear, the first thing you do is add the A and B together, A and C together, correct?
You would
Okay,
first
I'm just
you
trying.
first you multiply A times C, and then you find, so then you get an answer, and you find the factors of that answer that add up to B.
How do you find the factors to like add up to B?
This is probably incorrect, but I got x plus 1 times x plus 1.
Okay. I think something probably went a little bit south down in the
Sideways.
middle of that. So let's just draw the box together. How about that? So x squared goes here. And then what goes in the bottom right corner?
8.
Are you sure about that?
No, it's 15, I think.
Oh, wait a minute.
Yeah, it would be 15.
Now the box makes sense.
Yeah, if you put 8, that's probably what messed you up.
No, I
So-
didn't put 8. I was completely confused on what to put.
Okay.
I thought we were doing B, so I said 8.
Okay, so you put x squared into the top left and 15 into the bottom right. Okay, and now what we have to do is we have to do A times C. So remember, A here is going to be 1, C is 15, and 1 times 15 is 15. Now we have to find factors of 15 that add up to 8. So has anyone found those?
Yeah, 3 and 5.
Yeah, 3 and 5.
Yep. Good
3 and
job.
5.
Wait, why
What I
not
think-
like why not like 4 and 4?
Because Colin, 4 plus 4 does not 4 times 4 does not equal 15.
Just remember
Oh
they
wait.
have to be factors of
Oh.
15.
Colin,
Oh,
that's
I thought B had something to do with I don't know. Okay, I don't know.
So if you find yourself like struggling with the factoring, you can just write out all of the factors. And then you can also, remember these can be negative too, because 2 negatives can add up to 15. But anyways, the ones we found were 3 and 5. And now we're going to take those and put them into our box like this.
Okay,
Right.
now I understand what we were doing. I was completely confused on where the B came into play here.
Now that we've got the box, I'll give you guys, sorry about that, another minute and to see if anyone can come up with the fully factored form.
There's some answers in the chat,
Oh wait, did people get it?
and I think I kind of gave away that some of them were right. Or actually, everybody in the chat is right.
Ooh, okay. All right, good work. Oh, by the way, are you keeping track of points, Kayam? Okay. So points for you guys. And I'm sure all of you remember the next step here would just be to find the greatest common factors. So we have x, and then 5, and then x, and then 3. And our final answer will be x plus 5 times x plus 3. So good job, guys.
Okay, so I was just figuring that out and I was typing as soon as you said it. So do I still get the points? I was typing just now. Do I still get the points for that? Because I
You
knew.
only care about the points.
Shut up, Colin. I'm trying to.
We'll see.
Well,
I think we'll see. If you get the next one right, sure.
all right, next one. This one, you guys aren't gonna get help. All right, you guys don't need help for this one. You guys can do it all on your own.
Because right now we're going to do this like men.
Oh, are you sure you don't need help?
Okay, you can make this simpler. We're going to make it simpler. So basically just ignore the 3. Pretend like you divided the 3 out. And then you're just going to only do the box method. Wait. Yeah, you're gonna only do the box method on x squared minus 4x plus 4, just to make it easier on you guys.
We have some
Wait, what?
Who's
interesting
playing meme
background
music?
music.
You can't just do the box method directly on the whole thing, but it's probably easier if you just take out the 3 first and just do it on this part.
Yeah, everybody pay attention. You're not doing 3x squared minus 12x plus 12. You're doing x squared minus 4x plus 4. And there's only like one other person unmuted other than the teachers. Now there's more. So
I just started doing the one where you have the 3 in the equation. Now I have to start all over.
I mean, it's gonna be easier to start over than try to keep going with that.
No,
So-
I was on to something.
We're gonna keep going.
If you
So
get,
do we just not include the 3?
Yeah.
yeah, you can just ignore the 3 for now.
But
just
can
do
you do it with
x
the
squared
3?
minus 4x plus 4. Do the box method.
Get it right. I don't care however you do it.
I'm just gonna do it with the 3 in.
Oh no, looks like Colin's computer broke again.
Colin needs to fix his computer.
I'm stuck.
All right, what part are you stuck on?
So like on the box. So for the I have just 2 squares left. So I know that so like x squared plus 12 is 12. So 2 factors of 12 have to add up to negative 12 and multiply to 12.
Wait, so are you doing it on the original one?
No, I'm not including the 3.
Oh, well, when you don't include the 3, you have to basically divide everything in there by 3. So you have x squared minus 4x plus 4. Yeah,
Okay.
sorry if that was a little confusing. So once you finish doing the box method, what you just do is you just put the 3 back in front.
Is it x minus 2, x minus 2?
Format it with the parentheses.
Okay.
All right, so it looks like a lot of you guys are getting really close to the answer. As long as you,
Oh, it's one positive, 1 negative.
I'm not saying anything. You guys can figure it out.
One way to check is just like distributing. Then you can see if your answer is right or not. I see
What do you
some
mean by distributing?
like, like if it's x minus 2x plus 2, then like x times x plus negative 2 times x plus x minus x times 2 plus negative 2 times 2, like that. Like expanding.
All right, so let's do the box method. So first we put x squared here, 4 right here. And then we do a times c. So that'd be 1 times 4, which equals 4. Sorry, that's a horrible 4. And now we have to find factors of 4 that add up to negative 4. And that would be negative 2 and negative 2. So we're going to write that in the remaining boxes. Okay, now for the greatest common factor. So it would be x in the top row, it would be 2 in the bottom row, and then it's adjacent to that negative box. So you have to make sure it's negative.
I mistyped.
And the top one is x on the first column, and then the second column is 2, but then you put a negative because it's right next to the box that's negative. And now you have your factored form, x minus 2.
Wait, which one were we doing? Were we doing number 3?
Yeah, and then just remember if you took the 3 out at the start, you have to put the 3 back in at the front. So that will be the answer.
Wait, why is A 4? Is it 3 or 4?
A.
Yeah.
So A is 1. Well,
Yeah. What?
yeah, okay, so pretend like we just divided 3 out and then the 3 is gone. So then if you divide, the squeaks and metal clinking are not coming from me.
Where'd the 4 come from? Oh.
So what we did was
Oh.
we did 3x squared minus 12x plus 12, and then we divided everything by 3 just to make it easier. Then it turned into x squared minus 4x plus 4. And we just used the box method on that.
Let's do number 4 together and then should we move on?
Yeah. You want to do it?
Yeah, I guess I'll do it. And I did not say that was wrong because I didn't say anything was wrong, like ever.
You did.
You
Nope.
literally did.
What? What did I say?
You did.
I
Yeah,
did.
you did.
I can give you remote annotation.
Am I writing on it?
Yeah.
Oh, okay. So this is my very nice box, and mine's actually a box, not a like
Plus sign.
yeah.
That's plus.
So we have this, right? So I'm gonna write out like A, B, C form, like ax squared plus bx plus c, blah, 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 blah. So I'm gonna say 1 x squared minus 16x minus 36. So what do I do? Well, first I put this here and this there. So I'm gonna put x squared here. Oops. And then negative 36 here. This is kind of hard. Anyways, so now what do I do? Well, I multiply A and C. A is 1, C is negative 36. Well, 1 times anything is itself, so that's just negative 36. And now, I think this is the hardest part in my opinion. So, what I'm trying to do is find 2 numbers that multiply to negative 36, but add to negative 16.
It's positive 2 and negative 18.
Maybe. Does everybody agree or does anyone have a different opinion?
I pretty much agree.
You agree? Well,
Pretty
I
much.
think I also agree. Because negative 18 times 2 is negative 36. Negative 18 plus 2 is negative 16. So good job. So now we're going to put one of them down here and the other one up here. Doesn't
Wait,
matter.
why not? Why shouldn't it be like -6 and -6? Why does it have to be like -18 and
Because minus
two?
6 times minus 6 does equal negative
Oh.
36, but it also equals negative 12.
So the
When you
two
add it.
numbers, they have to multiply. So just say these circles are numbers. That has to equal C, which is negative 36 right now. But also this plus the other one, that has to equal B, which is negative 16 right now. So if we used your example of
Oh, okay.
negative 6, they add up to negative 12, not negative 16.
Okay, that makes sense.
So, okay, now we got this, right? So what do we do next? Well, we find the greatest common factors. X squared, 2x, well, that's pretty simple, just x. Negative 18x and then negative 36. Well, we know it's negative 18. Just pretend that's a negative sign. Now at the top, well, here it's just x. And here it's 2. Okay, well, this is a plus. This is already a minus. So the answer is right. Somebody said, I think it's that. Yes, Aniket. And you're right. It's x minus 18 times x plus 2.
Wait, no, he put x minus 18, x minus 2.
It doesn't matter.
Oh, whoops. No, it actually doesn't matter.
It
Yeah,
does.
Anushka.
So close.
I thought you just said it didn't matter.
When?
You said in the beginning of class it doesn't matter. It's the same thing as 3 times. You
That's-
said it doesn't matter.
That's if I switch these two around, like the whole thing. So I put in my answer x plus 2.
But 2x is right next to negative 36.
What did you say?
So in the box thing, 2x is right next to negative 36. So wouldn't it become negative?
No, so what we do for those is like, you look at the numbers on the side, like this, the ones we like wrote down on that side, this, and this. And this number, the 2, before we put the plus in front of it, was next to 2x, right? Like the closest to it is 2x, and that's positive, so it's a plus. And this was already negative, so doesn't
Can you
matter.
make a new diagram? Because I do not understand any of the numbers.
All right, let me change it to eraser if you stop moving. Okay. Wait, that didn't work. Okay, now.
Okay, so I'm gonna make a little bigger box. So I'm gonna
Try
have,
to make it a little neater too.
thanks.
You're
That was
welcome.
Uncalled for.
The absolute
That was
shade
out
and
of pocket.
disrespect.
See, you have to respect your elders. I'm turning 19 next month. So
No, wait, we were, what,
So you
how
just
old
called
were we?
yourself
We were
old.
50 or something. Remember?
It's okay. I just took like an anti-aging serum, so I just turned back a little.
Whoa.
Anyways. So what was this? Like,
2x.
yeah. And then negative 18, right?
X.
Is that neat enough for you?
Yeah.
Okay, good.
It's beautiful. It's a masterpiece.
Is that is in the 36? That a 6 or a 0 with the taking over? No,
It's
okay.
6. Is that better for you?
That looks better.
Okay, thank you. Now. Okay, so to make the sign thing easier, how about like you just always put the positive version so that it's less confusing. So here this 18 is next to negative 18x, right? This 18 is closest to this box. So that's why you put negative in front of it.
Okay.
This 2, the closest box to it is the one that's right next to, right?
Yeah.
Is positive, so you put a plus.
Okay.
And now you get this. And what I meant by switching around is that it can be like I wrote here, it can be this, but you can't change the signs because then it would be wrong. Any other questions? Okay, I think we're getting the hang of it. Should we do the next one or no? Like the next
You want
method?
to go to quadratic formula?
Yeah.
Yeah. All right.
Okay.
Now we're going to teach another method.
And I'm gonna teach it to you this time. Whoa. And yeah, we'll just skip that. Okay, so here is a very like complicated looking formula. And well, basically,
Oh,
this
wait, do you want to sing the song so they can remember?
I don't know the song.
Oh,
No music.
it's like
You
we
can
can
sing it
find it on YouTube. And then you guys, it's a way to remember this complicated formula.
Yeah, we'll just do that because we're fun, cool teachers.
Okay, let's do it.
Us too.
Let me just stop sharing for a second.
Anyways, this one is like you just memorize the formula and that's it.
Yeah,
Basically.
you can use the formula whenever.
You can use it for every single factoring problem ever. But also it's like annoying because it's such a long formula.
And it's
So,
slow.
I mean, that's why we try to teach. You're probably gonna riffle us again, so I'm not gonna click on that. Get ready. It's so short.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all
My
over
ears.
a.
So it's just like Pop Goes the Weasel. Okay, do you guys want to sing
The
it?
poor little weasel.
If you ever go to manual, then Miss Tatrum will sing this for you.
Pop goes the weasel, except 10 times worse.
Are you ready? Let's do it again. Wait, do you guys want to sing it together?
No, that's gonna be a nightmare.
Record
Never.
yourself singing.
No,
And
I
actually-
disagree.
Everybody knows you can't sing via Zoom.
I don't know, I've done it
Record
before.
your video and post it on Google Classroom.
Alright, just gonna play it again. If you want to sing, you can.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Even the weasel's tired. Even
Alright, so you guys can play that. You can sing it on
some
your
high
own.
schools, some high
Okay.
school choir sung that.
Yes. So yeah, this is our very amazing formula.
Apparently, they sang it while their vocal cords were going through puberty.
Okay.
Thank you for that.
Colin.
So, and the only thing you have to remember is that your equation is in standard form like that, like ax squared plus bx plus c. And then you just substitute the a's and the b's and the c's, and then you simplify and whoa, you're done. And should we go over the discriminant stuff? Or no? We have like 15
Okay,
minutes.
let's just go to solving something.
Yeah, we'll just like see this in action a couple of times and then that'll be it for today.
X.
Okay, so with my
Just a minute.
amazingly
Wait.
handwriting, I'll just show you.
Okay.
-2. Or would it be +2?
Okay, wait. So do we remember the quadratic formula, you guys? Negative
The
b
quadratic formula
plus
is
or
negative b plus or minus the
minus
square root
of b squared minus 4
4ac
all
all
over.
over 2a.
Beautiful.
This
I missed
is how you ear-rape people.
Colin, if you tell
Really
Colin, if you tell anyone else about that, there will be a punishment waiting for you on Monday.
So you need to plug these numbers into that. Oh wait,
Wait.
there's a 7. Okay.
Yeah.
Yeah. So first
Get
we
rid of
subtract 7 from both sides. And
That
then
until 7.
x squared minus 2x minus 9 equals 0. And now you can do the quadratic formula. So ignore this.
Okay, so -2x. So how do we determine if it's plus or minus?
Just remember this a x squared, a equals 1 here, b equals -2, and c equals -9. And then you just use that and do the formula. But plug these numbers into this formula up here.
Okay.
My question is, it's negative b and plus or minus. Which one do we do, plus or minus?
Just
Yeah, that's
write
what
the
I
plus
was
or minus
asking.
sign.
Also, would it be 2? Would for negative b, would it be 2 because b is already negative?
Yes.
Okay, so let's do it together. So negative b is -2, so negative b is just 2. And then you just write the plus or minus sign here because it comes into play later. Now the square root. So b squared is -2 squared, and that is 4. Now minus 4ac. So that's minus 4 times 1 times -9. All over 2a. And a is 1.
All
so it's
over 2a.
Yes. Okay. And now we simplify that further. So 2 plus or minus the square root of 4. Now that's 4 minus -36. So it'd be 4 plus 36 all over 2. 2 plus or minus the square root of 40. So you would have to simplify that down to, hang on, 2 radical 10. Yep. And 2 at the bottom. And then now you can simplify even further because you can divide both of the top terms by 2 and you get 1 plus or minus radical 10. And now what you do with the plus or minus is that gives you the 2 different roots. Because remember, like some quadratics will have 2 x-intercepts. So one of the roots will be 1 plus radical 10, and then the other one will be 1 minus radical 10. So as you can see, it's a really long way to do things.
But how do you know whether it's plus radical 10 or minus radical 10?
It's both of them.
What?
Because remember, like most quadratics, they have 2 x-intercepts, right? So those
So
are
depending on where the intercept is, that will be the answer.
no,
Like-
basically like once you get it all simplified and the only like thing you have left is the plus or minus, you separate it into like 2 different cases. Make one where the plus or minus just becomes plus, and then the other one is where the plus or minus just becomes a minus.
Okay.
So yeah.
In some of them, some quadratics will just have 1 root.
Let's do the second one.
Let me erase everything. Do you want to walk through it?
Sure.
Okay, oops, probably shouldn't erase that. Right, who still remembers?
I'm kinda
the quadratic
confused.
Equation?
The quadratic formula is negative b plus.
I'm kind
or
of confused. The quadratic song got stuck in my head and kind of jumbled up my thoughts.
So it wasn't helpful?
The quadratic formula.
No, it messed up my thoughts
plus or
on
minus
discriminant symbol thing.
plus
ignore
or
the
minus
discriminant.
b,
We're
the
not gonna go
square
over that.
root of
And
b
why is there
squared
square
minus
roots now?
4ab all over 2a.
Beautiful.
Okay. Can I have remote control?
Yeah.
And let's look at the second problem.
Woohoo!
I know, so fun.
Four
I'm
minus
not being sarcastic, guys.
Okay.
So this one is a bit more complicated. And first, what you have to do is, obviously there's like a -6 right there. And well, we need it to be set equal to 0.
Wait.
I don't see it.
So it says there's no numbers of real solutions. Is there any amount of numbers of unreal solutions?
So, I mean, don't think about that right now. It's gonna like make you more, like
Wait,
confused.
should we do a different one then?
This one?
Wait.
Wait, can you click next? I'm pretty sure it's fine.
Okay.
I'm pretty sure Colin was talking about
Oh, okay.
the past question. Anyway, so I moved our annoying -6 over, so now it's plus 35. So don't look at this. Okay, so we have our handy dandy quadratic formula, and I'm just gonna plug this in. So A is -2, B is +9, C is +35. And although it is painful, I'm gonna write out this whole thing so that you guys can see. So -b, so b is 9, plus or minus the square root of b squared, so b is 9, squared, minus 4 times a, -2, times 35.
Couldn't you just write 81 or
Yes, I'm trying to show you everything
okay.
the first time you're seeing it. So
Is it just me or like I can't really see anything you're writing down?
why? Oh, is it like not loading?
But yeah, is it just for me?
Can you see Yolanda?
I can see. Does anyone else have a problem?
I can see it.
I can see it.
Okay, I'm
maybe-
just gonna reload.
Yeah. Tell us if it like is still like that.
Wait, do I need to let her in again?
Anyways, I'll start on this side. So 9 times 9, 81. 4 times -2 is -8.
How did you get 81?
I just came from this, so the 9 squared is 9 times 9, 81. Oh, okay, good that you can see it.
Okay.
So what is -8 times 75? Well, that's 600, I think. Right?
Yeah.
Okay, so since it was -600, but there's like the negative in front of it already, minus a negative is plus. All over -4. Okay, now this equals, what is the square root of 681? Is that a perfect square or no?
Don't think so, right?
Could be like,
Oh, wait. No, it is 26. Well, it's not. It's okay
Oh.
to be simplified.
Let's see, 681. Here, I'll just write.
Wait,
Yeah.
so is that 81 plus 600 or
Yeah.
what is it again? Oh, okay. Wait, where's the 600 from again?
This is 600 is from this. The 4AC part.
So, oh, it's minus. Okay, never mind.
681. What factors into that?
It's
I'm gonna
divided
guess
by
that.
3, and then I think after that it's prime. So I don't think it can be factored.
So 9, then it's like 7.
Yeah, it can't be factored anymore.
Oh, okay. Yeah, you're right. It doesn't work. Okay, so our answer is this right now. And what we do is we make two different cases. The one where the plus or minus is positive and one where it's negative. I'm just gonna go up here because I have no space.
So basically the answer is -9 plus or minus the square root of 681 divided by -4.
Yeah, some teachers would just let you write it with the plus or minus in there. Oh wait, I did not mean to put that. We'll just make that the. Okay, I wasn't like thinking because I was talking. But anyways, some teachers would like you to like separate it into two different ones. Other teachers, they're more chill. And I guess we can be more chill teachers. So I don't really mind it. But yeah, so that's our answer. See, and this is why I don't like the quadratic formula. This is why we learn so many other methods for factoring, because we really want to avoid this while we can, because math people are lazy.
This is really annoying.
Yeah, it's extremely annoying. I agree.
It takes very long.
Yeah,
Yes.
it's mind-numbing. So it's 4:26, and I hope you learned something today. If you have any questions, you can stay behind. And our homework is it just a quizzes, you know? Yeah. So apparently it's just a quizzes, and
Well, I don't know.
it's okay if you don't like do on the homework because obviously we didn't cover all the things that was in this like presentation, but that's okay.
Try your best.
Yeah, just try your best, and if you get something wrong, it's okay.
That concludes our class. You guys are free to go. Thank you for coming and participating.
Yeah, thank you. Bye-bye. Oh, and
Bye.
just a reminder, we have 3 more classes and we're done for this like school year.
Sing Pop Goes the Weasel, Quadratic Formula version in your sleep.
Yep. Sweet dreams. Bye.
Homework is here, not the
Thank you.
Bye.
video.